We've cooked up an amazing integral for you guys today. It's absolutely ridiculous. It's the integral from minus pi over 4 to pi over 4 of sec squared x over 1 plus e to the power of x to the power of 3 with respect to x, of course. Now, let's go through this. Let's begin. Let's dive straight in, and I'm going to show you how amazing this is, because if you clicked on this video, you probably thought, whoa, that's a crazy looking integral. Let's see how we do it. So I'm going to do a substitution, and I'm going to let u, I'll write it over here, I'm going to let u be equal to minus x. We can also see that that would mean that du dx is minus 1, which would mean that du is minus dx, and we can use that. So if I rewrite my integral using that substitution, then when x is minus pi over 4, that's the lower limit, then u is positive pi over 4. And same thing, when x is pi over 4, I've got u as minus pi over 4. Okay, then I've got sec squared of x, which is the same thing as minus u, divided by 1 plus e to the power of x, and again, x is minus u to the power of 3, like that. And dx is the same thing as du, but with a minus sign, so I'll put the minus sign there. Okay, now this looks like a real mess. You might not really see the point in why we did that substitution, but now you will see how it all comes together. So I'm going to put the limits back the right way round, and you're only allowed to do that if you also times the integral by minus 1. So what I'm doing is I'm moving the integrals back around, so I'm making the upper limit the lower one and vice versa, but I'm also going to get rid of this minus sign, or in other words, I'm going to times the thing that's already negative by another negative to cancel it out. Okay, and you're allowed to do that, and then I'm going to use some rules here, some symmetry rules. So sec squared is 1 over cos squared. Now, cos is a function that doesn't care whether the number that you put in is positive or negative, right? So cos x is equal to cos of minus x. Same thing goes with when you square it, and same thing goes with when you take the reciprocal of that, and that's what sec squared is. So what I'm saying is sec squared of minus u is the same thing as sec squared of just u. They have the same graph, they're the exact same thing, so we can do that because it's an even function. And then we've got 1 plus e, and then minus u cubed can be written as minus u cubed, like that, without the brackets anymore. Now this is really, really remarkable, because now what we can do is we can notice that the limits of integration from the original integral and the one that we've turned it into are the same. And if we just change the letter of the alphabet here, because this is a u, if we just change this back into x's, or maybe a third letter if you want, like a t or something, we can essentially add the integrals together quite nicely. So let me show you what I mean by that. So if I say 2i, so I'm going to have 2 lots of I, the first version of it is the integral from minus pi over 4 to pi over 4 of sec squared x. This is the original question, plus divided by 1 plus e to the x cubed dx. And the other version of I is this, minus pi over 4 to pi over 4 of sec squared. And guys, just for the sake of simplicity, I'm going to rewrite it with x's instead of u's. We all know that u is a dummy variable here, so it doesn't actually matter what letter of the alphabet that you use. So I'm just going to turn the second version back into x's. And now we can see what we can do is combine them. So 2i is the integral from minus pi over 4 to pi over 4 of both of these integrands added together. So sec squared x over 1 plus e to the x cubed plus sec squared x over 1 plus e to the minus x cubed, all in one, okay? And you're allowed to do that because the limits of integration are the same. Cool. So now we have this. Now you might say you're making it so much worse, but guys, it's going to come together so nicely just in a minute. So let's rewrite our integral sign with the limits. And now what I'm going to do, guys, is, and this is the real, like, this is the trick basically, I'm going to take the second term and I'm going to multiply the top and the bottom of it by e to the x cubed. So I'm going to get e to the x cubed sec squared on the top, and then I'm going to get e to the x cubed plus 1 on the denominator. And if you're an eagle-eyed viewer, you might notice what's about to happen, or what has already happened. So because the denominators are the same now, 1 plus e to the x cubed, we can write this as one fraction. So this is sec squared x plus e to the x cubed times sec squared x. All of that is divided by 1 plus e to the x cubed. Okay? And hopefully everyone will have a moment in a second where they go, oh, I see what's going on. But just to spell it out, if there's anyone that doesn't see it yet, what we can do to the numerator is we can factor out a 1 plus e to the x cubed. So we've got sec squared x, big bracket, 1 plus e to the x cubed. And it's still divided by 1 plus e to the x cubed. And this is the really nice thing, because of course they cancel out. So that it turns out that we've just got the integral from minus pi over 4 to pi over 4 of just sec squared. Okay, amazing. Because 1 plus e to the x cubed just cancels out on the top and the bottom. And this is a remarkably easier integral, I should say. In a vacuum, I guess it's not easy, but it's so much easier because sec squared has a standard integral. Sec squared integrates to tan x. So this is just tan x evaluated from minus pi over 4 to pi over 4. Okay, and so basically we've just got tan of pi over 4 minus tan of minus pi over 4, like that. Tan of pi over 4 is the number 1, so it's 1 minus, and tan of minus pi over 4 is the number minus 1, so it's 1 minus minus 1, which is 1 plus 1, which is the number 2. And so the final step, of course, is to just divide both sides by 2, and we end up getting the final answer, I, is just the number 1, like that, because we have to half both sides because it was 2i. So that means that this integral, as absolutely crazy as it is, actually ends up just being equal to the number 1. I think that's amazing. So just to show you guys what we did one more time, we did a u-substitution. We could then realize that we could kind of rearrange it. We can add the integrals together, give them one fraction. They have a common factor of 1 plus e to the x cubed. Cancel them out. We end up with a much easier integral, just sec squared. And then we follow that working out. We end up getting 2, and then we half it because we added them together earlier. So the final answer is the number 1. Thank you guys, as always, so much for watching. I highly appreciate it. If you enjoyed the video, don't forget to subscribe, and I'll see you in the next epic inexorable maths video. Cheers.